Hi friends, welcome to Sia Digital Classes. Today in this video we are going to understand about Z-test. So Z-test is one of the parametric tests as discussed earlier videos. We have understood that parametric test has three techniques, that is T-test, F-test and Z-test. Now what is Z-test? So before understanding Z-test, let us understand about samples. So samples, we have understood that when the size of the sample is less than 30, it is small sample. When the size is 30 or equal to 30 or more than 30, it is large sample. So if the sample whichever are less than 30, the technique applicable is T-test, and if it is more than 30, Z-test is applicable. So what is Z-test? Let us see. So sample size or variables can be classified into two, that is sample size and large sample, that is small sample and large sample. So it checks if the means of two large samples are different. So Z-test will be helping us to test whether the samples are different, the difference of samples are different or same, and not when the population variance is known. So if the sample size is greater than 30, Z-test is applicable. If the sample size is more than 30, Z-test can be applied. And if the sample size is less than 30, T-test can be applied. So Z-test is statistical test that is conducted on the data approximately follows a normal distribution. Then the Z-test can be performed on one sample, two samples, or on proportions of hypothesis testing. It can be done one or two and according to the hypothesis testing. And a Z-test can be further be classified into left-tailed and right-tailed. So two-tailed will be there. One is left-tailed, right-tailed or two-tailed. Two-tailed hypothesis test depending upon the parameters of the data. Then computed value of the statistic Z is compared with the critical value, that is Z alpha, at given level of significance. And if the computed value of Z is less than the critical value, that is the table value Z alpha, null hypothesis is accepted. So what they are saying, if Z, whatever the value is calculated, computed value of Z is less than the critical value, that means table value, then hypothesis, null hypothesis is accepted or rejected in case of computed value Z is greater than the critical value. Okay, so what they are saying, computed value, that is calculated value, if it is less than the table value, it is accepted, and if the computed value is greater than the table value, it is rejected. Then what is the procedure for testing the hypothesis? So they say formulation of the hypothesis. So already we understood about the hypothesis in the previous videos. Now formulation, that is developing, passing or making a assumption, that is a statement for hypothesis has to be done first, that is formulation of the hypothesis, whether there is an association or not. So we may be passing a statement saying that there is no impact of the training. This is our statement. Now we have to see whether the hypothesis is accepted or rejected. And selecting a suitable level of significance. So we have to also select what level of significance we are going, whether we are going 95% or more than 95%. And that is 5%. 5% means it is the 95%. Then selecting the suitable sample distribution. So we have to also select the suitable sample distribution. Then drawing the conclusions. We have to draw the conclusions. Then you can see the procedure given in with the help of a flowchart. So first we have to formulate the hypothesis. Then we have to set up the level of significance. If it is 5%, it will be 95. If it is 1%, it is confidence 99. Then determine the appropriate probability distribution. Then compute the test. Okay. Then compare the calculated value with the table value. If calculated value is less than the table value, then it is accepted. Calculated value is greater than then it is rejected. Okay. So if it is accepted or rejected. depending on the value calculated. Then this is the problem given. Let us understand with the help of the problem by solving this. So a random sample of male employees is taken at the end of a year and the mean number of hours of absenteeism for the year is found to be 63 hours. A similar sample of 50 female employees has a mean of 66 hours. Okay, could these samples be drawn from a population with same mean and standard deviation is 10 hours? So state clearly the assumption you make. So first we have to develop the assumption, that is hypothesis. So hypothesis is samples drawn from the same population, that is the hypothesis, null hypothesis. Then alternate hypothesis, sample drawn the population with different means. It is two-tailed test. Then computing, this is a formula given. Z is equal to x1 bar minus x2 bar divided by standard deviation into root of 2 by n. Okay, then where x1 is equal to 63, that is male, x2 is equal to 66, that is female. So here it is standard deviation, they said 10, then sample size is 50. Now we have substituted in the formula, that is Z is equal to x bar is 63, x1 bar, x2 bar is 66 divided by the standard deviation is 10 and 2 by 50. So here it is, we got minus 1.5. So Z is equal to, we got the difference, that is variance, minus 1.5. So this minus 1 point is less than the table value. Let us see what is the table value at the 5%. So table value is Z 1.96. 1.96. So Z value lies in the acceptance region. Null hypothesis is accepted because the value is less than table value. Minus 1.5 is less than minus 1.96, the table value. Therefore, samples can be drawn from the same population with the same mean. So what we framed null hypothesis, that is same mean, it is accepted because the calculated value is less than the table value. So this is about the calculation, how we are going to calculate the Z test, how we are going to do the Z test. Hope this video is very much helpful for understanding what is Z test and how to do the problem. Thank you.